Concrete cover as specified in several codes we use, BS 8110 and other relevant codes we use in design, is actually to deal with a lot of things, to deal with fire. We know that we design building to be safe, so anything can happen. And you know that the more the cover, the less the reinforcement is affected because they are close to the edge. So the cover could vary from 20 to 50 depending on the structure, or even more. And also when you are building a hydraulic structure, underwater structure, any structure that is likely to receive water or any liquid, you have to have sufficient cover, because you know that the steel elements in the concrete may possibly be affected if you don't have sufficient cover. And a lot of things have to go with that. You have to densify the concrete. Well, that needn't be told anyway. It should be done. You have to vibrate the concrete, to use the layman's language, just to ensure that the steel is not affected, the concrete is not porous, water cannot enter, not whether the water is contaminated with other chemicals that are injurious to the concrete itself or to the steel embedded in it. So concrete cover in essence is to ensure that the building is safe from, not that the building will not be affected by fire if the fire incident is prolonged and it is not taken care of, but at least people should be able to evacuate the building safely before the building would eventually fail if the fire is not curtailed. So a lot of things, but more importantly, you put concrete cover there just to ensure that the steel is safe from being quickly damaged. It's a telltale sign that you don't have sufficient concrete cover, or the steel has been oxidized. And you know, steel, when it is oxidized, it expands. When it expands, it pushes off whatever it is that is actually harmed. So, and you see all these things begin to fall up. So when you see a building that has such a defect, the strength of the steel it has already been compromised, because the diameter of the steel comes to play in the course of testing. When you want to test, you take the length, which is a standard. It could be 600 or 700, 600, and then you take the diameter, and when you are calculating, you use all this to calculate the strength of steel. So once a steel starts to corrode, it is no longer at that required diameter again. So what you should do is you have to test, first of all, the integrity of the concrete itself, because concrete don't easily chip off if they are at of required grade. They don't easily chip off. So you have to test, where did the water come from? What kind of water? What is contained in that water? Why is this still oxidized? Why is it corroding? What is the level of corrosion? You have to understand all this. What element in particular are you talking about? Is it beam? Is it slab? Because you know that if it is a slab, you know that if the situation is isolated, you can quickly cordon off the place and see what you can do. If it's a column, you know that you have a bigger problem in your hand, because you already know that there are two other elements that are loaded on that. So and if it is foundation, you know that you have even more bigger problems in your hand. So if it is slab, for instance, you know that okay, you can quickly isolate the place, see what you can do, seek expert opinion, because you can't give what we call a straitjacket solution to a problem you have not seen, because every solution, you know, depends on what the problem really looks like. It could be that the concrete cover is not sufficient, so you deal with that. Engineer will tell you what to do when they see the problem. But if you say something now, people may think, okay, I think one size fits all, and you know, they can just go and do that, and that may not just be right for that situation at hand at that point in time. Yes.